In this lesson, we're going to cover what's referred to as the algebra of functions. And all this means is that if we have two functions, f and g, okay, we can combine them in a multitude of ways using our algebraic operations. So we've got addition, subtraction, multiplication, and division. Okay, so we have our four main operations, okay? And in the past, we've done problems where, when you were younger growing up, when you started out learning about math, you started with problems like this where you had 2 plus 3, okay? And you had to solve that. Here, we're just leveling it up, okay? Because now instead of 2 and 3, we have a function f and we have a function g, okay? So we're going to add these functions together and then we'll combine like terms. Okay, we can also substitute numbers in here for x and find the value at any given point. And we'll also do some practice with that. So this notation I know can look a little scary over here on the left. Okay, this notation right here. Some of y'all might prefer this notation. Okay, that might be the way you've seen it before. I'm good with either way. Just know that me and Alex are both gonna look at stuff using this notation. Okay, so one thing to note though, okay, when we think about these problems is we are going to have to consider domain, okay, to make sure that our functions exist. And for this class, okay, we only are going to need to worry about domain when it comes to division, okay? So only need to worry about okay, and the reason is because when we do division of two functions, notice we have this function down here on the bottom. And if you guys remember from last week when we learned about rational functions, we learned that the bottom part of the rational function, the denominator, okay, cannot equal 0. And when it does equal 0, we have a discontinuity. We have a gap in our domain where our function doesn't exist. So that's what this note is saying right here, is it's saying that bottom function cannot equal 0, okay? So it'll exist everywhere but at those points. So we'll discuss that some more when we do division, okay? We're going to start out doing these 3 scenarios, and then we'll do division. So we have two functions here, okay? So we've got f of x and we've got g of x. So if f of x is 2x minus 1, okay, and g of x is x squared plus x minus 2, we want to find the f plus g of x and f minus g of x of these two. So we want to find these two added together and subtracted. So what that's going to look like, and this is how I'll write it a lot of the time, guys, just to keep myself organized. I like using parentheses around each of the functions because it just helps me double check. Did I copy everything down correctly? Did I get everything that was supposed to be in that function g? Okay. And it's going to be necessary here in a second when we do like subtraction. You'll see why. So this is f plus g of x. Okay. And now because it's addition, okay, so I'm going to make a note, because it's addition, all right, you can ignore the parentheses, okay, and go, I'm going to use less words and just combine like terms. Okay, so we can jump straight into combining our like terms, which here we have some x's that can be combined, and we have a -1 and a -2 that can be combined. Okay, so for this problem, typically when I do these, y'all, if I have nx squared, okay, I'm going to write it first. That's just my force of habit, okay? You do not have to write it first. Again, that's just what I do, is I'll go from largest exponent to lowest, okay? So I always start with an x squared if it's there. For this type of problem. And then I'll go to my x term. So I have 2x plus x is going to give me 2 plus 1 gives me 3x. -1 and a -2 when combined give me a -3. And that's my answer. Okay, so the notation might feel scary initially, y'all, but I promise these aren't that bad once we get into them. We're really just writing these two equations down and then combining like terms. Okay. So when we go to do subtraction, okay, it gets leveled up a little bit from multiplication. I'm just going to copy and paste to make my life easier. Okay, so when I do subtraction, okay, why I said it was so important to do parentheses later on, okay, is because when we get to subtraction, I now need to take this negative and I need to distribute it to everything in that function g. Okay, so this subtraction sign needs to distribute into every single term in g. Okay, so we have to make sure we do that distribution here, which is why I always recommend doing parentheses. Okay, so I'm going to copy from that first equation as is, and then I'm going to distribute the parentheses to the second equation. So it'll look something like that, okay? And then I can combine like terms from here, okay? So again, that x squared term doesn't have anything to combine with it. So I'm just going to write negative x squared. And then I'm going to look at what can be combined. And I have a 2x and I have a negative x. And then I have some numbers. Okay. So 2x minus x is going to give me a plus x. Negative 1 plus 2 is going to give me a positive 1. Okay. And that is f minus g of x. Right. So again, f plus g is pretty... not too bad, all right? F minus g levels it up one step because we have to distribute that negative, okay? But very similar in the process here, okay? So let's do multiplication now, all right? So we're going to find f times g of x, okay? So I'm going to copy and paste this over and then do a little moving. So when I do this, you guys might remember this from way back, okay, in unit, I think it was unit 1 when we did multiplying polynomials. I think that was maybe week 1. So I like doing this section at the end because it's a great review of a few different topics, okay, multiplying polynomials being one of them. So when I have a 2-term polynomial by a 3-term polynomial, okay, I have to make sure I distribute everything in my first polynomial to everything in my second one. So I need to take the 2x and I need to distribute it to every single thing in that second polynomial. Okay, and then I'm going to do the same thing. I'm going to distribute that negative 1 to every single thing in the second polynomial. Okay, so when I do that, I'll get this. So 2x times x squared is going to give me 2. And x times x squared, remember, I have 1x times 2x's. That's going to give me 3x's in total. Okay, then I'm going to have a plus 2x times x gives me x squared. 2x times a negative 2, 2 times negative 2 is negative 4, and then an x. And then I'm going to do the negative 1 times each of these terms. So if I do that, I get negative x squared, okay, negative x, and then a positive 2. Okay. And from here, I can combine like terms. Okay, so again, guys, I'm going to write the term with the biggest exponent first, okay? So that's going to be the cubed, and it doesn't have anything that can be combined with it, so I just write it as is. Then I look for what else I have. I have an x squared here and here. I have an x, and I have an x, but I only have one number, so I can only combine my x squares and my x's. So when I do that, I have 2 minus 1 gives me a positive 1 x squared. And again, guys, you can write that 1. I typically don't, okay? I have a negative 4 minus 1, okay, which you can do in your head or your calculator. We'll get negative 5x, and then I'm going to bring down that plus 2, okay? And that is my final answer for this one, all right? So again, a little bit harder than when we did the addition and subtraction, okay? But once we get past that initial multiplying step, it's the same. We're just combining like terms and simplifying. Okay, so kind of same overall process to end the problem here. Okay, I am going to copy and paste 2 things over really quick to this slide. Okay, so we are now going to look at what happens when we substitute values in. Okay, so what I mean by that is, notice we now have this as our question. We want to know what is f of g of 3. okay? And when plugging values in for x, okay, if we did this with addition, subtraction, multiplication, division, we have two methods we can always choose from, okay? It's up to you which method you prefer and which method you choose. I don't care, all right? So I'm going to show you both methods, and then from there I'll just do the method that I prefer, but just know you have the option between these two methods for each of this type of problem. So for method 1, okay, we have f times g of x, okay? That's what this is right here. This, oops, let me get my pen. This is f times g of x, okay? And so what I can do is I can take this, and I'm actually going to make this condense a little bit so I can put an equal sign. Okay, I can take this, and all I have to do, okay, is I have to substitute in 3 anywhere I see an x. Okay, so that is going to be method 1. We take what we got when we did f times g, okay, and now to find, I keep writing the wrong thing, f times g of 3, okay, I plug 3 in, everywhere I see an x, okay, and then I can simplify that. All right, so that's method 1. So we can take what we get, all right, when we have that multiplication, okay, when we did the multiplication, and then from there we can just substitute the value in for x. Now this works really great when we have found f times g. You might not always know what f times g is, okay? So what you can do instead, okay, is you can look at it in its pieces, okay? So remember, f times g of x, okay, is the same thing as f of x times g of x, okay? So what we can do, okay, is again, look at it in the pieces. So we can take, I should have made these boxes horizontal instead of vertical. Okay, I can take this and I can, instead of everywhere I see an x, okay, I can plug in a 3. And I can do that in each function individually. So I can do 2, and then instead of an x, I'm going to plug in a 3 minus 1. And then here, again, I do big parentheses to kind of represent the full function. Plugging in 3 for x. And I always wrap things in parentheses when I substitute, okay? So that's what it looks like when I do it that way. Now, method 2 is great, again, when we haven't already multiplied f times g, okay? When we simplify this out, let's look at what each of these functions simplifies to first when we plug in 3. So notice 2 times 3 minus 1 is going to give me 6 minus 1 gives me 5, okay? When I do this, when I get 3 squared is 9, plus 3 is 12, minus 2 is 10, okay? So we get f times g of 3 is 50, okay? Now, same thing is going to happen over here, okay? I didn't finish simplifying this out, but if I did this simplified, okay, I would get the same thing. Get 50. So again, it's just going to be personal preference of which method you like better. I kind of go back and forth. I tend to prefer this method, but if I haven't already multiplied the functions together, I'm going to do this method, okay? So it's really just kind of what's the questions and what are the previous questions that have been asked will determine how I do the problem, okay? So 2 methods, again, your choice of which one you decide to use, okay? So let's look at another example. So we have 2 more functions that we're going to look at combining. Okay. And I'm going to repeat the process. So f plus g of x, I'm going to repeat the process. I'm going to go 5x minus 4, okay, plus 3x squared plus 2x minus 2. Okay. And again, I can jump straight into combining because I don't have subtraction or multiplication going on here. It's just addition. Okay, so I just can jump straight to combining like terms. And my like terms is the 5x plus the 2x is going to give me a 7x. The negative 4 and the negative 2 are going to combine to give me negative 6. Okay, and that is f plus g of x. Now I got to find f plus g of negative 7. Okay, so I'm going to go ahead and take what is already right here. Okay, so I'm going to take this and I'm going to plug negative 7 everywhere I see an x. Okay, and then I'm going to simplify this. So I need to type this one in my calculator. Okay. So when I do this in my calculator, I get 92. Okay, that was just a bit more mental math than I felt like doing. So we got 92. All right, when we do this one. Okay, so that is addition when we plug something in. So kind of the same, it's the exact same thing as when we did the multiplication, okay? It's just, I'm trying to think of the best way to explain it. Same process, again, the operation that we did initially is just different. So instead of doing multiplication, we did addition between our two functions, okay? So if you had done it out, you would have taken whatever you got for f of, let me put it this way, f of negative 7, okay, and you would have added that to g of negative 7. Okay, so this would have been method 2, okay, if you wanted to do it that way. Okay, so let's look at same two functions. Okay, we are going to look at f minus g and f times g. Is it the same two functions? Yeah. I'm going to grab this again, copy and paste to make my life easier. Make that subtraction. All right, and then we'll go ahead and look at both of these at the same time. So when I do, again, the top problem, okay, I have to distribute that negative. When I go to distribute that negative, I need to do it to every single thing in that second function. Okay. So the biggest mistake I see y'all make is pretend we didn't do any of the distribution. Okay. You write it like this without the parentheses. Okay. And when you write it like that, you only apply that negative to that first term of the second function. All right, so that is the biggest mistake I see y'all make. So that's why I like to make y'all / ask y'all to do the parentheses around everything. It just ensures that that won't ever happen. Okay, so I get negative 3x squared minus 2x plus 2. Okay. From here, I can jump straight into combining like terms. So I'll get negative 3x squared. Okay, my like terms here is going to be the 5x and the negative 2x, and then I've got a negative 4 and a positive 2. Okay, so this will give me a plus 3x and then a negative 2. All right, and that is f minus g of x for this one. Okay, so for multiplication, okay, I'm again going to go 2 term to 3 term, okay, like this. And I want you guys to take a second. I want you guys to multiply this out by yourself. Okay, see what you can come up with when you multiply this out. Okay, so that's what you should get when you multiply this one out. So here are the like terms that we can combine. We have an x squared term and an x squared term, and then we have an x term and an x term. So that gives us 18x cubed, okay, minus 2x squared minus 18x, and then plus 8. Okay, and that is the final answer for f times g of x for this one. Okay, so now I'm going to have you guys do some practice, okay, and there's a good bit of practice, okay. I want you to practice addition, subtraction, and multiplication, okay, and then I want you to practice plugging in a value into each of those, okay. So take a few minutes, okay, work through each of these problems, and then we'll review them together, okay? And I'm going to kind of stagger it, so I'll do the addition and show you the answers, and then we'll do the subtraction, I'll show you the answers, and then the multiplication, I'll show you the answers. So you could just do the addition right now. Okay, so the addition of f plus g of x for this one. We take our two functions, add them together, combine like terms. Here we have some x's that when we combine, we have a negative x plus x, which that just adds to 0. Okay, so we don't have an x term on this one in our final answer. We just have 2x squared minus 2. Okay, and then I took that and I plugged in negative 5 for x, okay, when I found f plus g of negative 5. Okay, now remember, you could have done f of negative 5 and g of negative 5, found each of those individually and added them together, okay, as our method number 2. Okay. So again, that option existed if you prefer that. So that is f plus g of x and f plus g of negative 5. Go ahead and do subtraction now if you guys haven't already. Okay, so for subtraction, all right, when we subtract the x plus 1 function, okay, that becomes negative x minus 1, okay, and again, we can think of these as being negative 1x and negative 1x, so when we combine those, we get negative 2x, okay, and then we have a negative 4, and then we had a 2x squared that couldn't be combined with anything, okay. Again, I chose just to take this and substitute in 8 for x, okay, and I got 108. So, fairly big number. Don't let the big number scare you, okay. Sometimes I know it feels like we should get numbers closer to 0, but don't let the big number scare you, all right? Especially when you have something like fairly big going in as your x value. Okay, let's do multiplication now. So if you haven't already done multiplication, go ahead and try the multiplication, okay, of f times g. Okay, so when we do multiplication, okay, again, I kind of color-coded it. I have to take everything in my first polynomial and multiply it by everything in my last polynomial. And guys, again, the way I like to do it is I always like to distribute my 2-term into my 3-term. So even though my 2-term is written here at the end, I distributed it into that green function f of x, okay? Because again, I just always like to go 2 into 3. You could have done it the reverse way, okay? You would have just had to distribute each of those 3 things into the 2 things. Up to you how you do it, okay? But this is how I chose to multiply these out. Okay, I got 2x cubed plus x squared minus minus 4x minus 3, okay? And again, I just took that, plugged in 13 for x, and I got 4,508, okay? So that is addition, subtraction, multiplication, okay? We are now going to talk about division, which I know division scares a lot of us. We feel like it's going to be the hardest, but guys, this is actually the easiest one, I think, okay? I'm going to show you why. We've got f of x, and we've got g of x, okay? And we are going to do f divided by g. So I'm going to do a big fraction bar, okay? And I'm going to write my function f on top, all right? And then I'm going to write my function g on the bottom, okay? And notice, guys, this notation right here, you'll probably see it written like this in Alex when you're doing your homework. Just know I wrote it this way because that's just easier to do in the Google Slides, okay? If I was doing this out on paper, I would write it this way, okay? So just a quick note about notation. Now, let's talk about f divided by g of x. We're done, okay? That's literally it, okay? There is nothing to be simplified here. We can't combine any like terms, okay? We can't do anything, okay? A lot of us get trigger happy, right? And we want to do something here, but this is all we do. We take f, we divide it by g. Okay, we just write a big fraction bar with our function f on top and our function g on the bottom, and then we move on, okay? Now, there are some cases where things might simplify, but to be honest, it's outside of the scope of this class. We're not really going to look at it, okay? So That's all there is to it. Okay, so again, this one might feel the scariest sometimes. I know division is usually the problematic operation. All right, but it actually is the easiest one when we're doing algebra of functions. Okay. When I go to do f divided by g of 2, all I'm going to do is I'm going to take this and I'm going to plug a 2 in everywhere I have an x. Okay, so it'll look something like this. Now, some of our calculators, depending on your calculator, you can simplify that really easily with all as one fraction. Okay, typically when I write this in just as like my showing my work, I typically will just simplify the top. Okay, so if I simplify the top, I get 2 squared is 4 times 2 is 8 plus 5 is 13. Okay, and then I'll simplify the bottom. So I do 16 minus 5 is 11. Okay, and a lot of times that's going to be your fraction. Okay, sometimes that'll simplify further and your calculator can help you with that. Other times that's just going to be our answer. Okay, so our answer here of f divided by g of 2 is 13/11. Okay, now the part where division gets a little tricky is we have to consider domain. Okay, we do need to write a domain restriction on these. So notice, okay, for these problems, g of x cannot be 0. It cannot be 0. Okay, we cannot have that denominator equal 0 because then we're going to be undefined. Okay, so our function doesn't exist at that point, so we just need to note when that happens. So I'm going to take my function g, so 8x minus 5, set it not equal to 0, and then simplify. Okay, so I get 8x, cannot equal 5. Okay. Then I'm going to get x by itself, divide both sides by 8. Okay, when I do that, I get x cannot be 5/8. Okay, so our function does not exist at 5/8. Okay, so again, our answer, we might look like that if it just says like, for what values of x does our function not exist? And you would write at x equals 5/8. If we do our domain and interval notation, okay, remember we're existing everywhere but this one point. So what we're going to do is we're going to go from negative infinity up to 5/8, really close from the left, and then we're going to be everywhere from 5/8 from the right up to positive infinity. Okay, so we have a little gap at 5/8, and that is how we can write this in interval notation. Okay, so that is division. All right, let's look at, we have some more to do to practice. Okay, so again, for division, okay, all I'm going to do is I'm going to take the top function, f, okay, and divide it by the bottom function, so negative 6x plus 3. We got x plus 4 times x plus 2. Okay, so for here, okay, that's all I do. All right, you could multiply this bottom part out. There's no reason to. Okay, you can leave it like that. All right, no reason to multiply that out. All right, unless it tells you to. But for me, no reason to multiply that out. Now that I say it, Alex might want you to, but I can't imagine that it would want you to do that. Okay. So I want you guys to take what we just found for f divided by g. I want you to find f divided by g of negative 6. Okay, so plug in negative 6 for x and see what you get when you simplify it down. Okay, so we just took what we found, okay, plugged in negative 6 everywhere we had an x. So on top, that top simplifies to 39. Okay, the bottom is going to simplify to a negative 2 times a negative 4, which becomes a positive 8. Okay, so 39/8 is our answer. All right, and that is f divided by g of negative 6. Okay, so for our domain, okay, again, that bottom function, which is g of x, cannot equal 0. All right, here we have two things in the bottom, okay? And remember, when you have two things and they can't be 0, okay, that means either this can't be 0 or that can't be 0. Okay, so we have two things that we have to consider, because if this is 0, 0 times anything is going to give me a 0 in the denominator, okay, and vice versa. So I have to take both and set them not equal to 0, okay, and then simplify. So if I subtract 4 here to get x by itself, I get x cannot equal negative 4. Same thing over here. I'm going to subtract 2 to get x by itself. I get x cannot equal a negative 2. Okay. Now, I have more than one thing, so I'm going to draw a quick little number line to help me write my interval notation. Okay. On my number line, I've got to put a negative 4 and I've got to put a negative 2 somewhere. Which one comes first on this leftmost tick? The negative 4 or the negative 2? Okay, it's the negative 4. Okay, and then I've got negative infinity on this end of my number line and a positive infinity over here. Okay, so what this looks like in interval notation is going to be negative infinity up to negative 4 union negative 4 to negative 2 union negative 2 to infinity. Okay, and again, remember, this portion goes with this portion of my number line. This portion goes with this portion, and then this portion of my number line. There we go. Goes with that portion of my interval notation. Okay, so I have 3 pieces on my number line. I have 3 pieces in my interval notation. Okay, so that is division. I'm going to have you guys practice one fully on your own now. Okay, so you're going to find f divided by g of x, f divided by g of 12, and then I want you to find the domain. Okay, so start with finding f divided by g of x. Okay, so for this one, we get 6x squared plus 2x minus 3 over negative 4x plus 4. Okay, so I took this first equation divided by the second equation, and I just filled these suckers in. Okay, so that is f divided by g. Okay, I'm going to now take that to help me find f divided by g of 12. So go ahead and find f divided by g of 12. Okay. So I'm going to plug in 12 everywhere I see an x. So that'll look something like this. Okay, and again, I'm going to simplify here. Now, if I simplify the top, I get 885. Okay, if I simplify the bottom, I get negative 44. Okay, now notice I have 2 kind of versions of my answer written down here. Both are valid to me. Okay, I don't know if Alex will be picky about it. I doubt it will. Okay, you can leave the negative in the denominator. Okay, some of us prefer to pull that negative out in front. Okay, and just write it out in front and then have your numbers. Okay, either way, totally fine. These are just 2, that W got really weird. 2 ways to write your answer. Okay. So that's all that is. Okay. All right. Go ahead and find the domain for me if you haven't already. Okay. So for domain, again, we're only worried about g of x. Okay. So I take my function g of x, which is negative 4x plus 4, set it not equal to 0, and simplify to see what value of x I cannot be. Okay, and I get x cannot be 1. All right, so in interval notation, that is negative infinity to 1, union 1 to infinity. Okay, and that is the algebra of functions. Okay, if you guys have any questions about any of that, please let me know.